Hey guys, Miss Shelley here. We're going to go ahead and move on to section 3 of topic 8, triangles. Let's go ahead and do a little review over triangles. So the first triangle I have here is an equilateral triangle. And what that means is that all three sides, here, here, and here, are all equal. Remember we talked about it in our last unit, drawing geometric shapes, that is what these tick marks mean, is that the sides are equal to each other. So an equilateral has all three sides equal to each other. You can kind of remember that equilateral, equal. Next, we have our isosceles triangle. Such a fun word to say. Isosceles. And it has two equal sides. I kind of remember you have these two S's here on either side of the O's, and you have these two E's here on either side of the L. And it kind of even sounds like it's a funny two kind of word. Isosceles, two same sides. And then finally, we have also the isosceles has two of the same two equal angles here and here. Those two angles will be the same measurement. Just like in the equilateral, all three of the angle measures on the inside are equal. And then we come over to the weird one, scaling. Scaling. That sounds like a weird word, doesn't it? Kind of reminds me of like a reptile. It's scaly. Scaling is unique because it has three completely different sides. None of the sides have the same measurement. And just like the sides, none of the inside angles either have any of the same measurements. They're all different, just like how all the sides are different. So just a quick little review, hopefully, that kind of reminded you a little bit more about triangles. So today we're going to talk about different types of triangles. The first type of triangle is what we call included. Now, I want you to kind of think of included and the next type, not included, not included. I want you to kind of remember included like this. You're included into your family. You're within, between your family. That is kind of what I want you to think about when you think of included. An included triangle is an angle that is either between two sides. So right here we have side A and B measurement. Ooh, I don't like that color. A and B, we know that A and B is 9, and we know B and C is 6. And we have an angle in between those two, angle B. So it is included, it's in between, it's within that triangle family. Just like how you're included or within your family, that is what an included triangle would look like. It would be a side right here. It would have an angle that's inside two sides. Or it could be a side that's in between two angles. For instance, you have angle D right here, and then you have this line, DE, and then you have angle E right here. So you have an angle, a line, and an angle. So if it's included, it's either an angle between two sides or a side between two angles. If it's not included, it's not in the family, then that would look like an angle that is not between two sides. For instance, right here you have BC and AB, and then you have angle C. That is not in between AB and BC. That is on the opposite side. That is not within the family. Or it'll be the same thing with angles. So you may have a side that's not between two angles. For instance, you have this side here, DE, but then you have the angle for D and the angle for E. In order for it to be included, you would need the side DE. So included is whenever you have an angle included in two sides, or you have two angles and the side inside. Almost like a sandwich. If you think about it, right here, This could almost be, you could think about this as kind of your side sandwich, with AB and BC being the slices of bread, and that angle B, that 34 degrees, would be your insides of your sandwich. The same thing with ED and F. Angle D and angle E would be like your bread, and that line DE, that 7, would be the inside of your sandwich. And then over here you just have just bread, and then 34, that C, that 34 degrees is just outside. It's not even in your sandwich. It's on the floor because you dropped it. So that's included and not included. Let's take a look now at what we call a unique triangle. Now, you know a triangle can be unique if it has one of these three things. The first thing is that it gives you the measurement for all three sides. So if it tells you that one side is 6, one side's 11, one side's 15, that's unique. There's no other triangle that can have those sides. You can take and you can rotate that triangle, right? This, I'm not a good drawer, but it's still going to have side 6, side 11, side 15. It's not going to change. Just because you rotate it, it's still always going to have those three side measurements. So it's unique. Another thing that another triangle that could be unique, sorry guys, is if you are given two sides and an included angle. So just like our sandwich, you have your bread would be your two sides, and your inside meat would be your angle. That also would be unique. You can rotate it all you want, but you will not have another triangle that has those particular measurements. And just like when we had the two sides and an included angle, you also have a unique triangle if you're given two angles and have an included side. So once again, that's like another sandwich. Angle B and angle C are like your bread, and line D or line BC, that 19, is like your insides of your sandwich. And those are what we call unique triangles. They're unique. There's only one. It's like each and every one of you. There's only one of you. There's only one of these triangles. Now, let's talk about if you have a triangle, it's more than one unique triangle. Whenever you have more than one unique triangle, it'll have one of these two elements. For instance, it'll have where it gives you all three angles. So it tells you that inside is 30, inside is 60. And in case you forgot, this box right here actually represents 90 degrees. So if you know the inside of all three angles, then that's not a unique triangle. There's more than one unique triangle. If you're given two sides, for instance, JK and KL, like we are right here, and then you're given an angle measurement that's a non-included angle, like J over here. Remember, JK would be like one slice of bread, KL would be like our other slice of bread, and then J, that angle 40, is what fell on the floor. It's your non-included lunch meat that's now on the floor that you're not going to include in your sandwich. So these two types of triangles means that they are not unique. There can be more than one type of these triangles. So before, there's only one triangle that can be just like these three situations, but over here, they're not that special, okay? You can have more than one of them. Now let's take a look at what happens if we have no triangle. And no triangle is kind of interesting. With a no triangle, you have to make sure that your two smallest links, when added together, are, oops, I wrote less than, and that should actually be greater than. Oh, Miss Shelley messing up. Wouldn't be a Miss Shelley lesson if I didn't mess up something. Just like in life, we always mess up, but all that matters is that we get going and we fix it and we learn from it. So, for there to be no triangle, you need to add your two smallest links together, and they have to be greater than the biggest length. So let's take a look at this triangle. If I have 9 plus 3, what is 9 plus 3? That's 12. So that means that is 12 less than or bigger than 16? It's less than. That means that this triangle right here is never going to connect. No matter how you move it or manipulate it, this triangle is always just going to fall shy of connecting. Okay? So it's never going to be a complete triangle. So in order for it to be a complete triangle, this side right here needs to be bigger than 3. It needs to be a number you can add to 9 to make it bigger than 3. So what's something I could add to 9 to make it bigger than that 16? What about 7? Oh, no, not 7, because 7 give me, oh, no, 7 plus 9 gives me 16. It can't be equal to it. What about 8? What if I now draw another line and I say it's not 3, it's actually 8? So I'm going to do 9 plus 8. What's 9 plus 8? 17. Well, 17 smaller or bigger than 16? It's bigger. So that means that this triangle will connect. Excuse my ugly line, connecting M and P, but in order for a triangle to be an actual triangle, the two smallest links need to add together and be bigger than the biggest link. So let's take a look over here. I have 3, 4, and 8. What's my biggest number here? 8. So that means that I need to add together 3 and 4, and it needs to be bigger than 8 in order for it to be a triangle. Well, what's 3 plus 4? 7. Is 7 greater than or less than 8? It's less than. So that means that this is no triangle because it will never be able to connect. So let's take a look at some examples. How many triangles can be drawn with side lengths 4 centimeters, 4.5 centimeters, and 9 centimeters? So the first thing that we need to do is we need to figure out what is our biggest side. Our biggest side here. Well, I'm looking at 4, 4.5, and 9. So my biggest number is 9. So that means I need to add together 4 and 4.5 to see if it is bigger than 9. If it's bigger than 9, it's a triangle. If it's not bigger than 9, it's not a triangle. So let's come over here and we'll do 4 plus 4.5. Add my decimal and add a 0. Bring my decimal down. 0 plus 5 is 5. 4 plus 4 is 8. So is 8.5 greater than or less than 9? It's less than. So that means that this is no triangle. Those sides of that triangle will never connect. All right. Pretty easy, right? So now let's move on and look at some more. It says, given two side lengths of 15 units and 9.5 units with a non-included angle of 75 degrees, can you draw no triangles, only one triangle, or more than one triangle? Let's go back to what we talked about before. And let's draw this. So I have this triangle. It doesn't have to be perfect. Oh, it doesn't need a tail yet though. Okay, so I have a triangle. The problem tells me that two sides are 15 and 9.5. And it has a non-included angle of 75. Remember, non-included means that's like you're making your sandwich and the bologna or the ham fell on the floor. So it's not inside your bread anymore. It's outside. So we'll put that one right here. So is this going, we know it connects. So is it one triangle or more than one triangle? Well, since my 75 is not included, then that actually means it is many unique triangles or many triangles. So, many unique. I can make more than one. It's not super special. All right, let's take a look at one more before I have you jump on over to today's practice. So you have a triangle, R, S, and T. So let's draw our triangle. I just made a random triangle. So this is R, this is S, this is T. It says 12 centimeters, 16 centimeters, and 19 centimeters. So I drew that this all connected. Before I can actually say it connects, I need to make sure that my two smallest links of 12 and 16 will actually add together and be bigger than 19. So let's go over here and let's do 12 plus 16. 6 plus 2 is 8. 1 plus 1 is 2. It's 28. 28 is in fact bigger than 19. So this is a triangle. So done. All right, so now I need to see how many triangles can be drawn from the given side links. We'll think back to our different triangle types. And what type is it if I have all three side links? If I have all three side links, then that means that I can only draw one unique triangle. And that's it, guys. That is all that we are doing. This lesson is easy. I hope you like it. I hope you have fun with it. I want you to hop on back over to Teams now and complete today's assignment. And please remember,